objectives is to compute payments and charges associated with installment loans, to identify the true cost of a loan by computing APR, and to evaluate the cost of buying items on credit. Before borrowing money from a friend, it's best to decide which you need most. Joe Moore. A lot of people celebrate their college graduation by getting a new car. Unless you're very wealthy, you won't be plunking down a stack of crisp $100 bills to make that happen. You'll need to get a loan. In this case, you'll be doing what is called installment buying. This is when the item is purchased and the buyer pays for it by making periodic partial payments or installments. There are natural advantages and disadvantages to installment buying. The most obvious advantage is that it allows you to buy an item that you don't have enough money to pay for and use it while you're raising that money. The most obvious disadvantage is that you pay interest on the amount borrowed, so you end up paying more for the item, in some cases, a lot more. When you buy a car, for example, you know the price of the car and you're usually told how much the monthly payment will be. If you're buying a car for $12,260 with a $3,000 down payment, and are told the payments will be $231.50 per month for 48 months, how much will you actually end up paying for that car? Work through this lesson and soon you will know. All right, we come down here to the bottom. It says here, fixed installment loans. A fixed installment loan is a loan that is repaid in equal payments. Sometimes the buyer will pay part of the cost at the time of purchase. This is known as a down payment. Here are some other key terms used to describe installment loans. We have the amount financed is the amount a borrower will pay interest on. Amount financed is equal to price of item minus the down payment. The total installment price is the total amount of money the buyer will ultimately pay. Total installment price is equal to sum of all payments plus the down payment. The finance charge is the interest charge for borrowing the amount financed. Finance charge is equal to total installment price minus the price on the item. Okay, now we go here to the top of page 288. It says, now let's take a look at the problem posed in this lesson's opening paragraph. The pertinent information is this: the cost of the car, the down payment, the monthly payment, and the term of the loan. What was the amount financed? Refer to the definition on the previous page if you need to. Okay, remember, the amount financed is the cost of the car minus the down payment is equal to the cost of the car is $12,260 minus the down payment, which is $3,000. So the amount financed, I'll put AF for amount financed, should have put that here. The amount financed is the cost of the car minus the down payment, and these are the values. So the amount financed is equal to $9,260. Now, number two, what is the total amount of all monthly payments? So it's 48 months times $231.50. 48 months, $231.50. Now, when we multiply all of that out, that will give us $11,112. Now it says, what's the total installment price? So we would take the $11,112 from the monthly payments, plus we would take the down payment, which is $3,000. So when we add them together, total installment price is $14,112. Now, it says find the finance charge, then describe what the amount really means. So we would take the total installment price minus, we would take the actual cost of the car, which is $12,260. That was the original price. And there would be $1,852 more that you paid. So you paid an extra $1,852 over the life of the car. And that is interest. You're paying extra money in order over the life of the loan in order to purchase that product. Okay, now we move on to the next page. It says here, in some cases, it's a good idea to be able to calculate a monthly payment before making a purchase. Not only can this help you to decide whether or not you can afford an item, it gives you a way to make sure you're not getting cheated when you're quoted a monthly payment. So how can you find the monthly payment for a loan? Using a formula, of course. Although to be fair, there are many loan calculators online. So we have our formula here. And we have what each of the letters mean. M, we know would be the monthly payment. P is the principal. R is the annual percentage rate. And then N is the total number of payments. Now it says memorize this formula and then eat it. Hold on, we're just kidding. Obviously, the formula is pretty complicated. You'll need to be especially careful when performing calculations involving this formula. An important note, if you do the calculation in stages, which we don't necessarily recommend, make sure that you don't round too much. This can change the calculation considerably. A reasonable rule of thumb is at least 4 decimal places. Now, let me explain this to you. Because you all can use Desmos, you have no reason to do this in steps. And when you're calculating this, I suggest that you put everything in the calculator and then only round the final answer, not in stages like they're talking about here. All right, it says in order to calculate the monthly payment on an auto loan, we need to know the annual percentage rate or APR. As we'll see shortly, this isn't exactly the same as the quoted interest rate for a loan. If the APR isn't quoted to you immediately when you start to talk about buying a car, ask for it. Salespeople are fond of steering the conversation toward monthly payments, but what determines how good or bad of a deal you're getting is the APR. You should always check local rates in advance of buying a car so you know what rate you should be getting. Number 5, have you noticed that car makers never have sales? They're always events. Weird. Anyhow, for the Honda 2019 President's Day event, they offered a certified pre-owned CRV with a special APR of 2.9% for 60 months. If one particular vehicle has a selling price of $27,295 and a buyer trades in an older car for a down payment of $4,500, calculate the monthly payment for this loan. All right, so we have P, the principal is $27,295. Now, this is how much the car actually costs. But to get the actual principal, we're going to have to subtract the 4,500. Because remember, once you subtract this 4,500, this will be your new principal, which would be, what is that, $22,795. Now your rate or your interest rate, so let me rewrite this. The principal will be $22,795. Your rate or interest rate is 2.9%, which is 0.029. And then the number of months, you're told that it's 60 months. So N would be 60. Now, we're going to take that formula formula is up here, and we're going to substitute. We have our principal, which would be $22,795, times the rate, which is 0.029, divided by 12, all over 1 minus 1 plus, the rate is 0.029, all over 12, and then it'll be taken to the negative 60th power, because n is 60. Now, we put this in our calculator. We could type everything as it appears here. So we had 22,795. Then I would suggest you press the division sign and then click back up to the numerator. Then we had times 0.029 divided by 12. Now we took care of the numerator. Now the denominator. Have 1 minus the parenthesis, 1 plus 0.029 divided by 12. Move the cursor over here, close the parenthesis, and now we would take it to the negative 60th power. And this would be our monthly payment. Our monthly payment would be $408 and then 58 cents, because our number system our monetary system typically only goes to 2 decimal places. So this right here would be your monthly payment, $408.58. Now on the back here, they have things here that you can use with the TI calculator. So you can read that at your leisure. But let's look at problem number 6 on page 291. If the loan was based on simple interest, the future value would be $22,795 times 1 plus 0.029 times 5, because we know 60 months is actually 5 years. It says calculate this amount, then divide by 60 to find the monthly payment. What do you think accounts for the fact that simple interest makes it higher? Okay, let's take this formula here, 22,795. Then we have our parenthesis, 1 plus 0.029 times 5. Then we will close our parenthesis. Now, they tell us here that we need to divide this by 12. And then our monthly payment, oh, you know what? It's actually, no, it was supposed to be by 60, not 12. Okay, so our monthly payment here would be $435. So our monthly payment, according to using a calculator, would be $435. Now it says with the fixed installment loan, the interest being, so what do you think accounts for the fact that simple interest makes it higher? Then we could just say it like this. With simple interest, the interest remains the same no matter how many payments you make. With compound interest, every payment reduces the amount of interest owed. Okay, now the annual percentage rate. Many lenders add upfront fees to a loan and then spread them over the life of the loan. This has the effect of making the actual interest rate that a borrower pays higher than the quoted rate. Because this can get confusing, lenders are required by law to disclose an annual percentage rate or APR that reflects the true interest charged. This allows consumers to compare loans with different terms. The mathematical procedures for computing APR are pretty complicated. So we're going to take advantage of built-in commands on a TI-84 graphing calculator for computing APR. This is described in a solved example. Okay, now we're not necessarily using the TI calculator here. So what we're going to do, if you want to use the TI calculator, again, it's on page 292. You can use this at your leisure. And the beginning of this was actually on page 290, but we're mainly using Desmos. So we'll go right over here to page 293. It says, when you take out a loan for a certain length of time with fixed payments, the usual path is to continue paying for the entire time until you don't owe anymore. But if you have the money to pay off the loan early, you can save some money because you don't end up having to pay the total amount of interest. But how much do you save? Is it worthwhile to pay a big chunk of money to save some on a finance charge? Let's take a look. The amount of the finance charge that you save when paying off a loan early is called unearned interest. There are a couple of methods that are used to calculate unearned interest. We're going to study one called the rule of 78. This is a formula that you can use to calculate it directly. So we have the rule of 78. U is unearned interest. F is finance charge. K is number of remaining monthly payments. And N is the original number of payments. So as a reminder, here are the specifics of the loan we've been working with. It says, let's say that we get a nice tax refund and consider paying off the loan a year early to save some interest. Using the rule of 78, to find how much interest you save if you pay the loan off with 12 payments remaining. You'll need the finance charge you calculated back in question 4. So we will have F is equal to $1,852. Now that is what we got back when we did question 4. Let me show that here. When we did the finance charge in question 4, we got the $1,852. Okay, now K, remember we want to pay it off with 12 payments remaining. So K is 12. And then N is the original amount the loan was for, which is 48 months. Okay. So now we will go through and substitute. You have U is equal to, now F is 1,852 times K is 12. Parenthesis, it'll be K, which is 12 plus 1. All over it says N, which is 48, times the parenthesis of 48 plus 1. Now we can put all of this in our calculator. So we have 1852 divided by, let me go back up. Then we'll do times 12. In parentheses, we know 12 plus 1 is 13, but I'm just going to type it in as is. Okay, now divided by 48, parentheses, and we know 48 plus 1 is 49, but I'm just going to still type it in as such. So this would tell us that the unearned interest was $122.84. That would be the unearned interest that we won't have to pay by paying it 12 months early. Okay, now, number 8. It says, in this situation, you would surely want to know how much it would cost to pay off the loan. The first step would be to find the total cost of all the remaining payments after the 36. So do that. So now we will have 12 times the 231.50. So that's how much will be left. So that's $2,778. Now that includes interest as well. Number 9, your answer to question 8 is what the payoff would be if you weren't getting credit for unearned interest, but you are. So subtracting the unearned interest you found will give you the payoff amount. So you would take this 2,778 and subtract off the 122.84 of earned interest that you would save. And that will give you $2,655.16. That would be the payoff amount. Now we go here to number 10. It says discuss the pros and cons of paying off the particular loan early. If you are in that situation, do you think it would have been worthwhile for you to pay it off? Now remember, everyone's going to have different pros and cons, but I'm just going to throw a pro out here. One pro is no more monthly payments. And a quick con would be you have to pay $2,655.16 in a lump sum. And what would I do if I was in this situation? It would just depend. It depends. Can I afford to hand over that large sum of money? To save $122.84. So that is a hard question that everyone will have to figure out for themselves. Okay, now we come here. We have, well, let me read this paragraph. It says, so far we've covered examples of closed-ended credit. This is credit with a fixed number of payments and a specific payoff date. We turn our attention now to open-ended credit, where there is no fixed number of payments or payoff date. By far, the most common example of this is credit cards. Since more and more people use credit cards for convenience, an understanding of open-ended credit is more important than ever. One of the easiest ways to end up in a really bad place financially is to not understand how open-ended credit works. Okay, now we have the unpaid balance method. One way that banks calculate finance charges on a credit card is the unpaid balance method. In this case, interest is charged only on the balance left over from the previous month. Suppose that you had an unpaid balance of $356.75 at the beginning of August and made purchases of $436.50. A payment of $200 was made during the month. The interest on the unpaid balance is 1.8% per month. Our goal will be to find the finance charge and the balance on September 1st. The billing cycle for credit cards and loans can begin and end on any day of the month. However, for the examples given in this lesson, we'll assume the cycle ends on the last day of the month. Now, number 1, find the amount of interest that would be charged on the unpaid balance. Show your work. It'll be 1.8% of $356.75. Now, let me show you how we got this here. It tells us here that we have a balance of $356.75 at the beginning of August. So it'll be 1.8% of this. which would be $6.42. So just to let you know, written out, it'll be 0.018 times 356.75. And that's what gives us our $6.42. Now it says use your answer from question 1 and the information about payments and purchases to find a new balance on the card. Show all your work. Okay, so we start off with the $356.75. But it's told here that we made a purchase of $436.50. And then we made a payment of $200. And then we would have to add on the $6.42 that we have up here, because that also will go for the balance at the beginning of the next month. So now when we add all this and subtract this together, this will give us $599.67. And this would be your new balance. Your new balance would be the $599.67. It's a lot going on there. Okay, now for the next page, we have the average daily balance method. Because a company that issues credit cards doesn't make as much money when users pay off the balance every month, they sometimes charge an annual fee for use of the card. Another way for them to make money from all users is to use the average daily balance method for computing the finance charge. In this method, the balance for each day of the month is used to compute an average daily balance, and interest is computed on that average. So in effect, consumers start paying interest on the day they make a purchase. Ouch. Calculations using the average daily balance method can be done in a series of steps, as illustrated by the next set of questions. The credit card statement shown here displays more detail on the account we studied in questions 1 and 2. Okay, so we have previous balance, we have purchases and payments. The goal is to find the average daily balance, the finance charge for the month, and the new balance on September 1st. The interest rate is 1.8% per month on the average daily balance. So step 1, find the balance on each day that a transaction occurred. Write the new balance next to each day listed below in the first blank. Ignore the second blank for now. So on August 1st, the start of the month, we had $356.75. Now, we're told here on August 7th, there was a purchase made of $59.95. So we have to add that value here. So I just typed it here. It'd be $356.75 plus the $59.95. So that would give us $416.70. Now, August 12th, another purchase was made of $223.75. So now, this balance will be $640.45. Now, a $200 payment was made, so we'll subtract that off, and that will give us $440.45. Then last but not least, on the 24th, we made a purchase of $152.80. So first, let me subtract the 200, and then add the 152.80. So it'll be $593.25. Now, so it says here, find the number of days for each balance. How many days was the balance? $356.75. Using the same idea, fill in the second blank next to each balance above with the number of days that the balance was at that amount. So basically from August 1st to 6th, which is actually 6 days, it was at 356.75. So from August 7th to August the 11th, so you got 7, 8, 9, 10, 11. That's 5 days. From August 12th to the 17th, that's another 6 days that it'll be $640.45. Now we got August 18th to the 23rd, which is another 6 days. And then August 24th, even though there is no numbers behind it, remember this month goes up to 31 days. So we'll go from August 24th to the 31st, which would be 8 days. Now listen, sometimes you may need to count the days by hand because you cannot just do regular addition with the different days because you have to count this day and then the days after it. Now, we move on to the next page, page 297. It says here, multiply each balance by the number of days and add these products. Copy the first two columns in the table below from your answers on the previous page. Then multiply to fill in the last column. So basically they want balance in number of days. So it'd be 356.75. Now with 6 days. We have 416.70, and that's 5 days. We have 640.45 for 6 days. Then we have $440.45 for 6 days. And then we have $593.25 for 8 days. Now what we're supposed to do is take these values here and take the balance times the number of days. And so when we multiply these values out, we do it for each day or each set of days. So I'm just going to multiply these out. This is just the Desmos calculation. Then when you add all of these up, it'll give you $15,455.40. Now it says here, divide by the total number of days to get the average daily balance for the month. So it says divide your sum from question 5 by the number of days in August. Now remember, it's 31 days in August. This gives you the average daily balance for the account. We have $15,455.40. And we divide that by 31 days. And it comes out to be $498.56. Okay, now we go down here to number 7. It says find the finance charge by calculating the amount of interest on the average daily balance. It says recall that interest on this card is 1.8% per month. How much interest will be due on the average daily balance? So the average daily balance of $498.56, and we'll multiply by 0.018. And when you put this in a calculator, it'll be $8.97. Now, step 6, it says find the new ending balance by adding the finance charge to the last balance. So we add $8.97 plus the $593.25. So the new balance would be $602.22. Okay, now It says each month when you get a credit card statement, there's a minimum payment that must be paid. Before 2003, these minimum payments had shrunk to the point that they didn't even cover the interest for the month. So if a cardholder paid just the minimum payment, the balance would continue to rise. In response to a public outcry, the federal government set new regulations in 2003 requiring credit card companies to set the minimum payment high enough that it covers the interest for the month, as well as part of the principal balance. The exact minimum payment formula varies some from company to company. This is not to say that make a minimum payments only is a good idea. If at all possible, you should always pay off the full amount each month. This is the only foolproof way to make sure that you don't get in the habit of spending more money than you can afford. We'll close this lesson by examining the effects of making only minimum payments. Okay, it says here, suppose you have a $2,300 balance on a credit card with an interest rate of 1.25% per month, and the minimum payment for any month is the amount of interest plus 2% of the principal balance, or $20, whichever is higher. If you don't make any more purchases on that card and make the minimum payment for 6 months, how much will you pay down the balance? Let's find out. By the way, the interest and minimum payment percentages in this problem reflect industry averages in 2019. This certainly sounds like we'll need to compute some interest. After all, we were told that the interest is 1.25% per month, but sometimes problems contain extraneous information. Read the problem carefully and explain why we don't need to worry about the amount of interest in calculating how much the balance decreases. It says the minimum payment is 2% plus the amount of interest. So each month you would pay interest, then 2% of the balance that remains. So the balance is decreasing by 2% each month. It's not that much, but it's still something that it is decreasing. Okay, now we go over to the next and last page. It says, in fact, what really matters is that the balance is going to decrease by 2% each month. Use this fact to find the new balance after 1 month. So basically, if the balance decreases by 2%, 98% remains. So we take 98% of $2,300. So let me write that out. We have 0.98. 0.98 times 2,300, and that would give us 2,254. That's how much will remain. It says repeat your calculations from question 10 5 more times to find how much the balance would have decreased after 6 months. So we know 1 month, we already have 2,254. 2 months, now we would take 98% of the 2,254, and that would give us $2,208.92. So we had a third month. Or I should just say 3 months, not third month. So at 3 months, we would take 98% of this 2,208.92, and that would give 2,164.74. Now we keep doing that. We have 4 months. 0.98 times that $2,164.70. Oh, that's supposed to be 74 cents, not 70 cents. All right, so that would give us $2,121.45. So we have 5 months, 0.98 times 2121.45. That would give us $2,079.02. And then for 6 months, we have 0.98 times the 2,079.02, which would be 2,037.44. Now it says, just make a guess. How long do you think it would take to pay off the full balance at this rate? Discuss the actual instructor to give their thoughts on the question. Okay, your answer will vary on this. So yeah, we could play around with it and everything like that. But it does seem like a very good question. So let's see, how can we figure out how long this would take? All right, first of all, we've already been given an equation. We'll start off with the initial amount. The initial amount was $2,300. And remember, we did this before. Times 0.98, and then we would take it to the x power. Let me put y equals in front. Now, when I said we've done this before, I believe it was chapter 1 when we did exponential and linear regression. And so, well, it might have been chapter 2. So let me do a table here. Now remember, we're trying to find basically how long it would take to pay off the balance. Now if we scroll here a little bit, just want you to see the visualization. We look here, we notice that it's going to be between 350 and 400. So let's try $360. Well, let's go back. 300. Let's try 200. Oh, that's too much. I mean, too little. 250. Oh, 240. 239. 41. 250. 250. 230. Oh, put too much there. So 230. 231. Now I'll explain to you why I'm typing in these numbers. Let's see, 232. 233. Look like 234. 235. Yeah, about 235 payments. Okay, let me explain this to you. Earlier, when we looked at problem number 9, it said in the direction, it says that you would pay the minimum payment for any month. Oh. It says the minimum payment for any month is the amount of interest plus 2% of the principal balance, or $20, whichever is higher. So basically, when we get here about the 234, yeah, about 235, at the 235th payment, that's the closest we will come to $20, because once we get here, we will pay that and that will pay it off. So when they ask us, how long do you think it would take to pay off the balance in full? That'll be 235 months. So with that being 235 months, if we break that up, let me see, that'll be almost 20 years. So we could say it would take 235 months to pay off the full balance. So it's saying basically if you make minimum payments, you'll be paying almost 20 years to pay off whatever balance it was off of this card. Now, that is it. If you have any questions, feel free to email me and let me know. Have a wonderful day.